Alright, so continuing from chapter 1, where we saw the basic emission and then emission based on attributes, we will start looking at how to calculate point velocity. So if you have like a moving object, then how to take care of that. And then a few other things like how to add some basic forces to your particles as well. So first of all, let's do one thing. This is fine. I'm going to get rid of the mask altogether. Okay, so I'll just set up to mask and make it additive. So what we have is just this, but I'm going to animate it. So I have, that. Okay, so we have a little bit of, so we have a continuous emission rather than just like a fixed emission. Okay, so the first thing we want to do is we're going to take something called as a point velocity node. Okay, so this is I don't know if this is a new node, but it's there in Houdini 18. So this does a lot of things. Like previously, in order to calculate point velocity, you had to use like the trail SOP, which had this option called compute velocity. But now you can do all of it within the point velocity, which is sort of like, I believe it's like a digital asset that covers a whole bunch of things. Now, even if you don't have a moving object, this still gives you a fair bit of things. Like what I'll do is I'll just come into the pop network and I'll get rid of the variance. Okay, so we just have like a fixed emission like this. So what I can do is I can come into the point velocity. Now the first option it says is use, it can compute velocity. Okay, so we don't want that. Okay, because we don't have any velocity right now. So what you can do is you have this option called curl noise. So you can add some curl noise. But beyond that, you also have this option for adding velocity. Okay, so if I add like some existing velocity of let's say 1, then you'll get this. Okay, so it's already sort of like computing velocity. So what you can do other things is you can add some curl noise. Now you can visualize this. So if you can come in here and I'll just connect it to the visualize node that we had, and I'll set this to V. So you can see like you have, curl noise. You can also set this to, instead of attribute, like instead of color, you can use a marker and the style can be vector. See, so you're getting like, we'll just lower the length a little bit. Yeah, and then if you press play, see you have this. So what you can do is if you come into the particle network and press play, so you have, like curl noise based velocity, and I can come in here and I can lower the scale of it. So it won't move out as much. And you can also have like the pulse duration. So if you want it really fast moving, or if you want it very slow moving, you can do that. And then you have other options, like you can do the size of the noise. Okay, you can add more grain. Like grain will make it very rough, and also like increases the intensity of it. Okay, so you can do this stuff, which is nice. You can also add like a conical noise. Okay, so you can decide the cone angle. And you can also decide a direction. So let's say if we make it in the Z direction and press play, see, and then you can sort of like open up the cone. So you can do stuff like that. Okay, and then you can also import something from an object. So if you have like a moving object and you want to apply that motion to it, you can do those things. But mostly what you can also do is you can apply the object's own motion. Okay, so what I can do is, let's say if I just take a transform here, okay, like before the point velocity, and then in the x-axis I'll just do a sine of at frame. So I should get some basic movement, which is very slow. So let's do one thing. Let's take the frame, we'll multiply it by 5. So it's fast. And then I can, I don't want it to, by default, it's going to go between -1 and +1, which you can see here. Like if I zoom out, see this is 1 and this is -1, and you'll see it go between 1 and -1. But let's say I just wanted to go from like 0.2 to -0.2, so I can do multiply by 0.2. Okay, so the movement will be shorter. Okay, and then if I come into point velocity, and it's kept on compute from deformation, So if we look at the velocity now, so you'll see it, generating that velocity. Like if you don't have this, okay, like if you don't have the movement, and if you play it, it'll just do this. Okay, now what you can also do here is a couple of things, like since it's just moving like that, okay, you have this option in here which says interpolate source. So you can see like there's some banding happening over there. If you do the interpolate source, it will try to sort of blend it. See, so now you don't have as much banding. So you can do positive or negative, like you can do forward or back. So when you have a moving object, usually keep this on. Okay, like don't keep it to none, otherwise you'll get banding. But now what we want to do is we want to turn on point velocity. So now you can see it calculate and move based on velocity. See, there you go. So you can do based on that, and then we can add some curl noise to it so it will look a little more fancy, maybe a lot lower. And let's also do one thing, let's increase the life a little bit. So let's make it about 2 seconds. So there you go. Okay, so this is fine. Now another thing you can do is it can also calculate the velocity based on the object deformation. So rather than just having it move, what I can do is, let's say if I add like a mountain sop in there. Okay, so I'll just apply like a mountain. We'll lower the height, and yeah, we'll lower the element size, and I shall lower the roughness. And then I'll just like animate it using the time node. So I can just make it at time, which will animate this. And so it can calculate velocity from this as well. So if you look at the visualize, you'll see that it is, computing velocity based on that. Maybe just lower it a little bit. And so now if you look at the particle network, this should give me, like if you don't have the point velocity, you're not going to get any of this movement. See, it's just going to do this. But because of the point velocity, you're getting something a little more fancy. And you can also adjust the point velocity. Like if you want, now if this is like your basic movement and you want to maybe, multiply it with something else, or, make it go faster or slower, then you can always just come back here to the attribute, and then we can increase the, inherit velocity. And so that will make it go faster. So yeah, so the point velocity node is actually quite helpful. Alright, now one thing that I missed out in the previous chapter was we saw how to emit based on attributes, but let's say if you want to emit based on groups, so you can also do that. Okay, so what I can do is, let's say if I make a group, okay, like let's say we'll make a group before the mountain. Let's say I make a group here, and I'll make it using a bounding box. I'll place it there. Okay, and I'll just call this emit. So what I can do is I can come in here to the pop network, and I can just come to this place, and I can say source group is like guess from group. If it's not showing you, you can try just typing it. So what is it called? Yeah, I think it's just called emit. So let's try to type in emit, and there you go. Okay, so if you don't see the name of the group, you can just type in the name. But there you go. So you can base it on on a group as well. And this is useful because if you are emitting from an attribute, you can only emit, as I said, you can only emit from surfaces. If you want to emit from points using attributes, that's not possible. So what you can do instead is you do a slight bit of a workaround. Okay, so what I can do is I can come here to my attribute noise, and I can come to, I can just take a delete. So when I want to emit from points, but base it on the attribute that I have, this is the workaround. Okay, so you can come into a delete, and I can say delete by expression on points, and we can do at mask, let's say less than 0.5. See, so what you have is, you have this thing left. And so now if I come into the particle network and I'll change it to points, and let's call this as, sorry, yeah, you don't need to call it anything because now your geometry itself is gone. Okay, but now you can emit, based on points like that. Okay. So it's computing velocity, which is a little weird now. Let's do one thing. Let's take the point velocity after the delete. Yeah, okay. This is, so let me just lower that a fair bit. Or let's just bypass this for a second. Let's see what we get. Yeah, so it's sort of like it's emitting based on, the deleted geometry. Okay, not the best effect that you can get, but it works. But yeah, we'll bypass this, we'll bring this back and we'll go to scatter onto surfaces, which is better. Alright, so now that we've seen how to set up the basic sort of point velocity and emitting from attributes, let's apply like a couple of forces. Okay, so we just have, I'm going to work with two of them, which are the absolute basic. So you can take a pop force, which will give it, you can give it basic directional force, and you can also give it noise. Okay, so it's pretty simple and straightforward. It's like a general force that you can use for a whole bunch of effects. So I can do a bunch of things here. Let's do one thing. I'm going to turn off the mountain temporarily, and we'll also turn off the point velocity. So we just have this. And what I can do is, I can just, now, before we continue, I just remembered something, okay. What if you want the particles to just move out in the direction of the normals? Okay, because that is also something that you want sometimes. So what you can do is fairly simple. Just take a wrangle. This is like a final thing for point velocity. And just set at v, which is your velocity, equal to the normals. Okay, so the normals of your geometry will become your point velocity. So if you look at it and visualize, see, that's what you'll get. And then if you look at the particle network, you'll get this. So it's just, your particles moving out in the direction of the normals. Okay, and then you can just come in here and maybe lower the inherent velocity. If you don't want to lower from here, you can just come into this one itself and then just take another at v and say multiply by equal to, we'll create a parameter for this. So we'll just call it, say, speed. And I can just create that. So now, since you're multiplying it with a value, you can just give it, how fast or slow it should be. So let's keep it slightly fast. Yeah, okay, that looks fancy enough. Okay, so now that this is set up, let's take a look at our particle force. Okay, so you have a bunch of things here. Let's get rid of this. And you can give it a force. So I can give it, like a y-axis force. So it'll just move. Now, if you start to see banding, okay, which is what we're seeing, one of the ways to get rid of it is by increasing the substeps. Okay. So what you can do is you can come to your particle network and you have an option for substeps. Okay, which is it's going to calculate like in between frames. Okay, so let's say if we keep the substeps to 3, that means it is calculating like every 1/3 frame. So you'll notice that it will slow down, but you won't get the banding. So if you're moving too fast and you're starting to see banding, then you want to increase substeps. Now, another thing you can do with these guys is you also have the option to use vex. Okay, which is if you turn on use vex, and you'll get some basic things here, like you can say randomize magnitude. Okay, so let's say on a per particle basis, you should have like different movement. So what you can do is you can just click here and you can say randomize magnitude, which is what it's doing is this is called force. So it just creates a force and it's multiplying it with like a random value. Okay, so just to sort of do this, ourselves, is like if I just take force and we say equal to, and I can do like set 0, 2, 0. So this is going to override, what is happening there, and see, there you go. Okay. Or if I make it 0, 0, 0, then you're not getting anything. So what I can do is I can create like a basic random function. So I can say float, let's call it R, equal to, we'll randomize the ID. So which is the ID of every particle. Okay, so we'll randomize at ID, or let's make it slightly bigger. So we'll do like fit 0, 1. We'll randomize the ID between, let's say 0.3, 2. So it's going to be a fairly big range, and that comes in here. So so y-axis will be R, and if you press play, see, you'll get this. Or we can go negative as well. So I can say like between -1 and +1. So if you press play here, see, you're getting this. So you can use Vex and do more fancy things with it. Okay, let's turn this off temporarily. Let's turn that off as well. And then you can just give it noise. So let's say if I give it some curl noise, so you'll get basic noise. And again, you can do the same thing here as well. So you can use Vex expression, and if you keep your mouse on it, it'll tell you what is the parameter name, and that's how you modify it. So if I look at the parameter name and it says AMP, so I can say AMP, let's say multiply equal to, we'll say randomize the ID. Okay. So this is a very simple way to just randomize the amplitude or randomize anything. See, so now you're getting a more randomized intensity. Like if you turn this off and press play, see, they're all sort of moving out at the same speed. And then if I turn this on, like if I want to compare this, like a very simple way to compare it is I can just do Control-C, Control-V at SOP level. So we have 2 of them. I'll take a transform and let me just move it to a side, and we'll merge it together. So we have both of these, and then what I can do is I can just come into this one and come into the pop force and turn off Vex expression. So what you should get is, see, this one has no randomization and that one has randomization. So it's pretty easy to make out the difference. Okay, so that's what you can do. So you have a whole bunch of stuff here that you can kind of go through. You have mostly the same stuff. You have like swirl size, pulse length, roughness, whatever values you want to change. Now, along with this, if you want the particles to sort of slow down, because right now they're not really slowing down, they just kind of move too fast. So the simplest option is you should add some drag to it. Okay, so what you can do is you can just take a pop drag, and we can just add some drag to it. And so that will kind of, so you get a much more sort of controlled motion overall. Okay. Let's do one thing. Let's come into the pop force. I'll just modify this again. So we'll do fit 0, 1. I'll do comma 0.5, comma 1. Okay. So all of them will move just at different speeds. Yeah, so this is essentially it. Now, before I close this lesson, let's do one final thing, which is a slightly more complex version of a drag. Okay, now, one of the things you can do is you can apply color to particles at particle level. I don't usually do that. Usually I apply color at SOP level because you should do it as a post process, so it's faster to calculate. But what you can do is if I take a pop color, and let's say you want to color it based on the age, then you can just come in here and say ramp, and the default ramp goes to age. Okay, now it doesn't go to age, which is the interesting thing. It goes to something called as a normalized age. Now if you want to see the age attribute, okay, see, so there you go. Like, let's just switch this. So you're starting from white and then it fades off to black. Now a particle generates a bunch of parameters, like it generates age and it generates life. And if you want to see these, you can just, we'll split pane left and right. I'll set it to the geometry spreadsheet, and then we'll just have to sort of go in a bit, find it. So if we'll come to geometry, there you go. Okay, so you have all of your various values or attributes. And then the age is based on seconds, so it sort of keeps going. Okay, like your age is now 2, so it's not going to fit in a ramp of 0 to 1. Okay, and then similarly you have the life of a particle, which is where? Yeah, so the life is like when each particle is born, it's given a specific lifespan. So you can see like particle 1 has a lifespan of 1.9, okay, which is based on the, like if I give it a life variance of 0, see every particle has a life of 2 seconds. So life is the total life that it has, and the age is the current life that it has. Now what we want, or what the normalized age does, is it sort of takes that and fits it between 0 and 1. So it's easy to apply like a ramp to it, or you can then apply like a whole bunch of forces based on the normalized age. Now the problem with normalized age is that you can't access it. It's a virtual attribute that Houdini makes, but you don't have access to that. Okay, so using it becomes complicated. Now, but you want to use it because it's quite useful. So how do you use it? Okay, so the simplest option is that you make your own normalized age. The formula is fairly straightforward. Is you want to use a fit function, and you want to fit the age starting from 0 to the life of the particle, and then fit it between 0 and 1. Okay, so that's the formula for normalized age. So what we'll do is we'll take this, I'll do Control C, and I'm going to take a pop wrangle, and I'll create my own attribute. So I'll create f at, let's call it b age. Okay, because you can't use n age. If you try to type n age, it's not going to work. Okay, because it's a pre-stored virtual attribute somewhere hidden inside Houdini, and then you can't access it. Okay, and then we'll do this and then put a semicolon at the end. Okay, so now we have an additional attribute called bh, okay, which should be there. There you go, you have bh. And then if you want to know that it works, I can just come in here and I can type in bh, and it should give me the same result. Like if I press play, see, I'm getting the same result. So now the big question is, what do you do with this? And you can do a lot of things with this, which is where it becomes interesting. So I should be able to access it within my force as well. So let's see if it works. So what I can do is I can take the amplitude and I can say multiply by, we'll create a ramp. So let's take ch ramp and we'll use at bh. We'll create a ramp first. So let's call it, so it needs to be given a name. So we'll call it intensity, and then it will use bh, and then close it. And let's open this up, and if we press play, it should give me something interesting. See, so when it reaches a certain age, because the ramp is like this, so if I, press it like that, and I'll just change this color to, it can use speed, so we'll just set it to speed. I'll show you a form, like the speed formula is very simple, but we'll deal with that at a later date. And you can set, like if you click on the gear, you have options for different colors. So let's set it to two-tone. I like two-tone. So if I press play, what's going to happen is after it reaches an age, after it reaches a certain age, it will start moving, which should give you something very interesting. So if I press play, see, so only after it's reached a certain age, it's going to move. And if you want to reverse it, I can reverse it. So I can just take this up here and take this down there and press play, and you'll get see they stop or they start to slow down. But you can use this very nicely for generating a drag. So if you want like an age based drag, this is pretty interesting. Okay, so I can just, let me just, modify that. And instead of this drag, what I can do is I can take another wrangle, a pop wrangle. We'll call this age drag. And what you want to do is you want to just straight up multiply the velocity. Okay, so we'll just take like at v multiply by equal to, and let's pick up the same thing. So I'll just pick up this. So Control C, come into the drag and Control V and create this. And what we should get is, what you want to do is, in the beginning the velocity is 1, and then towards the end it sort of starts to slow down. So if you press play, you'll start to see, yeah, it's a little too much. Okay, so let's just do one thing. This is going out to 0.3, right? So I want like all the way till here, till a life of like 0.7, it should be the same. And then it slows down. Okay, let's get rid of the Vex expression here. Or let's just go back. Like this one, I want to go back to the fit01, make it random at ID. Yeah, okay, so this is fine. We're not using the ramp anymore. See, so what's happening is that once it reaches a certain age, it suddenly just slows down. Like it completely just, stops it. So if you wanted to slow down based on age, then this is a very nice way to do it. Like if I keep it like that, so you can then define it very interestingly. Okay, like how it should work. Okay. But yeah, like it works in both places. Like you can do it here, which is interesting, and you can also do it within the force, which was interesting as well. So let's say if I do it with the force as well, like I can just pick up this whole thing, do Control C, come in here, multiplied by Control V. Okay, let's press play. Yeah, and what we can do is, let's say it's, it moves in the beginning itself. So we're getting this, and then it slows down, speeds up, slows down, speeds up. Okay, this should give us something interesting. Let's turn off the drag temporarily. But yeah, it should give us, like different results that we weren't getting before. So having it multiply with the normalized age gives you, far more interesting things. So maybe I can like slow it down here and then speed it up again. I don't know, let's see how that works. Yeah, it slows down completely. So there's like the momentum goes away. But yeah, so this is one final thing that I wanted to show before we start going towards more, complex nodes and stuff, which is how to use the age of the particles to control the forces. Okay, so which is very important. Like you want to do that at certain points in time. Like maybe after a few bounces you wanted to slow down or stuff like that. Then this is where it really comes into play. So the next lesson, we're going to take a look at particle collision and the basics of particle groups.